Hello and welcome back. In section 5.2 we get to work with integration by substitution. So this is basically the integral relative of the chain rule. So one of the properties we'll look at, if dy over dx is the same thing as f prime of x, then we can also say that dy is f prime of x times dx. And if we integrate both sides of that, then y is worth f of x plus some arbitrary constant c. So for example, let's say that we have, let's let y equal f of x, and f of x will be x raised to the fifth power. So then dy over dx is 5x to the fourth power, so dy would be the same as 5x to the fourth times dx. We've seen that property in motion before. So where we actually start putting this to work for us is when we're looking at integrals that are more complex than what we looked at in the previous section, but that can be solved using just a little bit of substitution. So the first one we'll look at is the integral of the quantity 6x plus 1 times e to the quantity 3x squared plus x minus 10. We'll set up and multiply by dx. So generally, when you have e to a power and you're looking to integrate, that exponent will be your u substitution. So we're going to let u equal 3x squared plus x minus 10. So then du dx is 6x plus 1. In other words, du is 6x plus 1 quantity times dx. So notice we have a 6x plus 1 and we have a dx. That part is going to get replaced with a du. I'll leave a little room here. E didn't get replaced at all. E stays as an e, but the 3x squared plus x minus 10, we said that that was the same thing as u. So this is integral of e to the u times du, a much less complicated antiderivative. So this would be e to the u plus arbitrary constant c. And then the only other thing we have to remember to do is get it back in terms of the original variable. So u is the same as 3x squared plus x minus 10. So this antiderivative is e to the 3x squared plus x minus 10 plus arbitrary constant c. Now it may take a little bit of trial and error to figure out where to make the u substitution, but with a little practice it does get a little bit easier. Next one, we'll look at the integral of 10x over the quantity 5x squared plus 2 quantity cubed times dx. So here it looks like this part, the 5x squared plus 2, is sort of the main feature of the problem. That's going to be my let line. That'll be my u. So I'm going to let u equal 5x squared plus 2. So du over dx is 10x. Du then is 10x dx. And then once you've done this a couple times, generally you'll start kind of skipping to going right from u equals 5x squared plus 2 to du equals 10x times dx. Yes, you do have to have the dx. So then a little bit of substitution. So I see a 10x times dx. That will get replaced with du. And here we'll just continue this over here. The 5x squared plus 2 is our u. So integral of 1 over u cubed, so that's the integral of u to the negative third times du. So that is a power rule, u to the negative second times negative 1/2 plus arbitrary constant c. And then we get our original back into the problem. So this is negative 1 over 2 times u squared, so times 5x squared plus 2, quantity squared, and then plus arbitrary constant c. So that gives us our family of solutions to that antiderivative. Okay, so I'm going to have you all try one out. Let me make sure I'm lined up nice here. There we go. All right, so it's up to you to figure out your substitutions on this one. We'll do the integral of quantity 5x squared by 5/3 x cubed plus 7 quantity raised to the 99th quantity times dx. So see if you can come up with your substitution and find that integral. Welcome back. So our let line, we're going to let u equal this argument inside here, 5/3 x to the third plus 7th. So that means our du, 5/3 times 3 is 5. X cubed is now an x squared, and we'll multiply by dx. Derivative of a constant, of course, is 0. So I have a 5x squared and I have a dx. Those two pieces now get replaced with du. I also then have this 5/3 x cubed plus 7 to the 99th, so now that is u to the 99th power. So we've made something that is less complicated to integrate. So I'll bump that exponent up by 1, multiply by the reciprocal, and add c. So then that would be 1/100th of u gets replaced with 5/3 x cubed plus 7 quantity raised to the now 100th plus arbitrary constant c. One kind of question that I've seen a few times teaching this course, this problem, or its rough equivalent, is basically, can I also distribute that? Not with this exponent, you cannot. If it's raised to the first power, then yeah, go ahead and distribute, but you cannot distribute it to these two because of this exponent. The easiest numeric way to give yourself a counterexample to that is just do 2 times, well, let's say 5 plus 7 squared. So that's 2 by 12 squared, 2 by 44 gives you 288. If we were allowed to distribute that, we should be able to get 10 plus 14 quantity squared to equal the same thing, while 28 squared is definitely not the 288. So just a quick counterexample, this stays as a factor. Okay, So let's look at, we didn't get to play with these yet. Next up, another integral of a fraction, x cubed plus 5 upstairs, downstairs a quarter of x to the fourth plus 5x minus 7, all of that multiplied by dx. If it looks like one is the derivative of the other or a multiple of a derivative of the other, go ahead and grab that sort of quote-unquote bigger one and set that as your u. So I'm going to let u equal a quarter of x to the fourth plus 5x minus 7. So du is then x cubed plus 5 quantity times dx, and I have both of those pieces. So now I have the integral of du. This part is a 1 over u. So that is, hopefully you remember, natural log of absolute value of u plus c. And then we just put the original back in. And that's as far as we go with integrating that pretty little integral. Alright, let me have you all try one more. So integral of x cubed plus 5 all over 1/4 x to the fourth plus 5x minus 7 quantity cubed times dx. So similar to another example, but not quite the same. So go ahead and pause it, give that one a spin, and see what you can do with that one. Okay, so our u, like before, is going to be the 1/4 x to the fourth plus 5x minus 7. So then du is x cubed plus 5 quantity times dx. So then we have integral of this times dx is du, and we have 1 over u cubed. So then that's integral of u to the negative third times du. So that's u to the negative second, multiplied by its reciprocal, add c. So negative 1 over 2 by u squared. And don't forget your arbitrary constant, our buddy c. For the next couple, I want you to recall a property that we have used previously in our integrals. Integral of c times f of x dx is the same as c times integral of f of x dx. And remember, equal signs don't mean carry out the operation, they mean has the same value as. So I can either pull a constant factor out or move a constant factor in as well. Both of those are allowed. So that's just a handy little tool coming up for the next problem. So this next one we'll take a look at integral of 7x squared e to the x cubed plus 2 quantity times dx. So like before, the exponent of the e is usually going to be your u substitution in these one-step substitution guys. So let u equal x cubed plus 2. So du, hopefully you're able to do that while I'm sort of pausing here for you to catch up. 3x squared times dx. What's making this one a little bit different is I see the x squared, I see the dx. I wanted to see a 3 there. I see a 7 there instead. So what we're going to do, we're going to take advantage of that property I just mentioned. So the 7 is going to move outside. I'm going to leave a little bit of space here. We're going to need that space in a second. integral of, and again I'm going to leave a little bit of room, x squared e to the x cubed plus 2 quantity times dx. And what we're going to do is we're going to multiply by 1. So I wanted to see a 3 there. I'll multiply by 3 here and 1/3 here. 3 times 1/3 is 1, so we've really just multiplied by 1. So we just changed the look of it. So 3x squared times dx. There's our du that we were after. Outside we have a 7/3 now. So we have 7/3 integral. I'll leave a little room. All the stuff I underlined in blue is now eaten up with our du. Then we have e to the u as well. So hang on to your 7/3. Antiderivative of e to the u is e to the u plus c. Now you might notice I didn't throw this in parentheses. The reason for that is 7/3 times a constant is still just a constant. So a constant times a constant is still a constant. I don't need to group those two together if it's just one term that involves variables and then just a constant. So then we'll just get back to our original variable x. So 7/3 e to the, remember u was the same as x cubed plus 2. And then we have our friend the plus c at the end. So if you are just sort of missing the constant that you want, you're always, remember, allowed to multiply by 1. It doesn't necessarily work the same way with variables, but constants, no problem. Okay, so let's try. We'll pick out a couple of problems from your author. We'll try integral of e to the negative 3x times dx. Using this u substitution, we'll try integral of x over x squared minus 9 quantity times dx, also using the u substitution. And we'll try integral of 5t squared by t cubed plus 4 quantity to the negative second times dt. So go ahead and try those three, see what you can do with them, and then we'll look at another one that has an interesting twist on it. Okay, welcome back. So our first one, our let line is going to be let u equal negative 3x. So du is negative 3 times dx. So I want a negative 3 there. I don't see a negative 3 there yet. So we'll take one step and do our multiplication by 1. So I will multiply by negative 3 inside and negative 1/3 outside. E to the negative 3x times dx. So that's negative 1/3 integral of e to the u du. So negative 3 dx is our du. E to the negative 3x is our e to the u there. So we then have, let me try to squeeze this in, negative 1/3 e to the u plus c. So then that's negative 1/3 e to the negative 3x plus arbitrary constant c. Our second one, the easiest let line would be let u equal x squared minus 9. So du was 2x times dx. If you're noticing that I'm writing stuff down that you're not writing down in your problems, make sure to correct that, since that will lose you some points on quizzes and tests and such. All right, so I see an x dx. I don't see a 2 here, so again, we'll just use that idea of multiplying by something worth 1. So we had the x dx. We were missing the 2, so multiply by 1/2 outside and 2 inside. So now we have 1/2 integral of 1 over u times du. So that's 1/2 natural log absolute value of u plus c. And then we just put our original back in it. So 1/2 natural log absolute value of x squared minus 9. Should make my absolute value line a little straighter there. And plus arbitrary constant c. And our last one. The best choice for our u this time was t cubed plus 4. So then du is 3t squared times dt. I see the t squared, I see the dt, but I have a 5 that I want to get out of the way. So we'll move that 5 outside. I want a 3 in there that I didn't have, so multiplying by 1 to get that job done. So now we're ready to do our u substitution. So 5 times a third is 5/3. Integral of, we have 3t squared times dt. That is our du. T cubed plus 4 is our u. And it's raised to the -2nd. Much prettier integral than what they started us with. So 5/3. U to the -1 multiplied by the reciprocal. -1 is its own reciprocal. And plus c, so -5/3. And u is t cubed plus 4, -1st, and plus c. So you'll see it either written this way or with this in the denominator. And just raised to the implied first power. Two different versions of the same thing. Alright, so next up is one more little trick to these substitutions that we haven't had to use just yet. So we'll do integral of x over square root of the quantity x minus 5 times dx. So here it would be easiest to let our u equal x minus 5, which means our du is the same as just 1 times dx, or just dx. So I see the dx there, I see the x minus 5 here, but I have an x alone. This didn't have an x factor. What I can do with that is take this u equals x minus 5 and rearrange it, getting the x by itself, so I can sub it in something written in terms of u. So I'll just add 5 to both sides of this guy, and x is the same as u plus 5. So there's just sort of one more option we have as far as substituting things in. So I'll hang on to this integral. X will get replaced with a u plus 5. X minus 5 is still a u underneath the square root or raised to the 1/2 power, and dx gets replaced with du. So this one, hopefully you notice that we can split the denominator, split the single fraction into the two separate fractions. Again, this is one of those 1/7 plus 2/7 and 1 plus 2 quantity over 7 things. We're taking the single fraction and splitting it up. So this is integral of u over u to the half plus 5 over u to the half quantity times du. So integral of u to the 1/2 plus 5u to the -1/2 times du. So then we're just doing the power rule from there. So add 1 to the exponent, so that's 3/2. I'll need a 2/3 factor there. And your plus 5, add 1 to the exponent. Reciprocal of a half is 2. And we have our friend the plus c there. And then we're just putting the original variable back in. So these u's get replaced with x minus 5s. So then our final answer is 2/3 x minus 5 quantity to the 3/2 plus 10 x minus 5 to the 1/2 plus arbitrary constant c. And I have you all play with a similar one. And this is another one of your authors. So integral of x square root of the quantity x plus 1 times dx. So go ahead and give that one a spin with the substitution method. Welcome back. So here let u equal x plus 1. So then du here is also the same as dx. I see an x plus 1, I see a dx, but I also see an x floating by itself. So if u is equal to x plus 1, then x is equal to u minus 1. So we have integral of, that x gets replaced with u minus 1. X plus 1 is the same as our u, and we're raised to the 1/2 power. Dx and du are the same here. So here, just a little bit of distributive property to use. So then this is integral of u to the 3/2 minus u to the 1/2, close it up, times du. So add 1 to the exponent, multiply by the reciprocal. Add 1 to the exponent, multiply by the reciprocal. Add our constant, and then just a little cleanup and putting the original back in. So this would be 2/5 times x plus 1 to the 5/2 minus 2/3 x plus 1 raised to the 3/2 plus arbitrary constant c for our final answer on that one. Okay, so some problems I would recommend trying out. This was section 5.2, 9 to 49, every other odd, and 59 to 75, also every other odd. If you have questions, please get in touch. Otherwise, I'll see you next time. Stay safe out there.